Whenever we create any variable, whenever we declare a variable, what happens is compiler or C++ creates some memory for our variable, or it allocates some memory for our variable, and then for that variable, whatever name we give, that name will be assigned to that memory location, or that name will be attached to that memory location. So till now we used to say that the compiler is going to allocate some memory, C++ is going to give us some memory. In this video we are going to discuss what is that exact amount of memory we are going to get for different data type, for variables of different data types. So let's quickly start with the first data type, that is integer data type. So for integer data type we get 4 byte of memory. Compiler is going to allocate 4 byte of memory. Okay. For character data type variable, compiler is going to allocate 1 byte of memory. Now what is this byte? See, byte is a commonly used memory unit. 1 byte represents 8 bits, okay, and 1 bit is I'll say it's the smallest unit of measuring a memory. 1 bit represents a single, I'll say single cell of the memory, so it can either hold 0 or it can hold 1. So bit is the smallest unit, and 8 bits make 1 byte, okay. Float data type takes 4 byte of memory, or float data type variable is going to get 4 byte of memory. Double data type variable is going to get 8 byte of memory, and boolean data type variable is going to get 1 byte of memory. So integer 4 bytes, character 1 byte, float 4 byte, double 8 byte, and boolean 1 byte. Okay, so I hope you are clear on these numbers. Now these numbers are actually not fixed, they change depending on your machine. So you can see that in front of some numbers, in front of integer, in front of float, and in front of double, you can see in the size in byte column I have written ID in bracket. Now what that ID exactly means? See, ID means implementation dependent. So on some machines it may happen with the older machines, you will get 2 byte of memory for integer. It may happen for older machines that you may get 2 byte of memory for float. So for some data type it might happen that size is different on different machines, but there are some data type for which the size is going to be fixed. Doesn't matter which machine you are using. For example, character is always going to get 1 byte of memory. Doesn't matter which kind of machine you are using, whether you are using old machine or a very latest machine, doesn't matter, it's always going to get 1 byte of memory. Similarly, even the bool variable or bool data type variable is always going to get 1 byte of memory. It doesn't matter which machine it is. But the variables of type integer, float, and double may get different amount of memory or different size of memory depending on the machine that you are using, and also depending on the compiler that you are using. So size of variable depends on 2 factors. First is the machine architecture, I'll say, or the hardware details of your machine, and second is the compiler that you are going to use or that you are using on your machine. So that's why in the brackets that I have written, it is implementation dependent. That's why I have written ID in the bracket. Now always remember, this is very interesting. See, whenever we talk about size for a variable, so whenever we say that integer variable is going to get 4 byte of memory or character variable is going to get 1 byte of memory, so there is going to be restrictions on how many values or how many different values we can store in that variable. See, because we have limited memory, it's not like infinite memory. So let's take example of character. For character we are getting only 1 byte of memory or only 8 bits of memory. So if we are getting only 8 bits of memory, then there is going to be limitation on number of values or number of different values that we can hold in that memory location. And that's the reason for each and every data type or for variable of each and every data type, we are going to have a range of allowed values. So let's quickly see what is the range for character data type. So for character data type, the range is -128 to +127. So you can store values from -128 to +127. So the minimum value or the smallest value that you can store in character data type variable is -128, and the maximum value or the largest value that you can store in a character variable is +127. Now you might be having this question in your mind that when we talk about character, usually the characters are like small a, capital A, then hash, at the rate, such kind of things are called as characters. But in this case, why we are talking in terms of numbers? So for this, my friend, we have a special video called as how characters are stored in the memory in C++. So in that video, you will get an idea about how characters are dealt in C++. Right now, just don't focus on that part, because characters are treated differently in C++, or I'll say in all the programming languages. For programmer perspective or for user perspective, they look like small a, capital B, but internally they are handled differently. So for that, do check out the video on how characters are stored in memory. Okay. Similarly, for each and every type, let's say for integer, we have 4 bytes, so that is limited memory. So you can see even integer variable is going to have some range. Now I'm not going to read that number because it is really big, because 4 byte is a big space, I will say. But you can see for it's going to have some minimum value and it's going to have some maximum value.